So far, our equations look like this. A sine bx, A cos bx. But what do those values mean again? Well, remember the A has a specific name. The A stands for amplitude. Now, remember what the amplitude means. If we've got a graph who has got a center line like here, we have an amplitude up and we have an amplitude down. Those values are our A values here and here. But you notice that that one A value has to actually describe both the crest and the trough. So that's one of the reasons why whenever we're talking about an A value here, we always put an absolute value on it. We worry about the negative later. Okay, cool. Now, the next thing I want to worry about here is the B value. Now, here's where a lot of students make a mistake. They think that the B value is the period. No, it's not. The B value is what determines the period. Oh, I see. So what do I talk about that? I'm actually talking about, surprisingly enough, I'm talking about a horizontal stretch. You betcha, because normally sine and cosine graphs are 2 pi in their period. But when you put a B value in there, and remember, don't get stung, you have to divide by the B. When you divide by the B, that determines our new period. Oh, I understand now. Cool. Okay, so I've got a great question for you. Ready for this? Check it out. It's right here. Look at that. Now, remember, here's our A value. No, it's not. You have to absolute value that -2. There's our A value. That's our amplitude. Oh, okay. And here we go. There's our B value, right? Our B value is 2. So remember, don't get stung. Our period is actually 2 pi over the B value, which is 2, cancels out. Our period is actually pi. Gotcha. Gotcha. So what does this mean? How do we turn around and apply this all to a graph? Well, I'm going to show you. I'm going to show you something that is absolutely going to boggle your mind. It's actually called the magic box. Well, magic box? You mean it's magic? Yeah, kind of. Okay. Let me show you how it works. In a normal sine graph, remember, in a normal sine graph, you would start here, you would go down, and you would end here, right? Normally, that complete cycle, the up cycle and the down cycle, happens in 2 pi, in the period, right? But check out what our period is. Our period, in fact, is only pi. So our total cycle from start to end now happens in pi. That's what period tells us, and it's helped and determined by this B value. Cool, but what about the amplitude? Well, think about it. The amplitude is this measure right here. It's the measure 2. We figured out the amplitude to be 2 right here. Okay? So it's 2 here, and it's 2 down here. So guess what that gives you? That gives you the maximum up here, and that also gives you, guess what? The minimum down here. But our amplitude still remains as 2. Up 2, down 2. Okay, then, I got a question for you. If you look at our original question right here, it has this wonderful negative in front of it. Well, how does that come into play? Well, guess what? This, in fact, is a vertical stretch factor. That's a vertical stretch. So what does this mean? This means a vertical, haha, you guessed it, it's a vertical reflection. So instead of going up now and then down, a reflection means you're going to go down first and then up. So instead of going this way, you're actually going to go down first. Oh, my goodness, I'm so confused. Don't be. It's not that big of a deal. Let me show you how Magic Box works. Soon as you see Magic Box, you're going to freak. Ready for this? Okay. The first thing I'm going to do is I'm going to recognize the fact that this is my amplitude of 2. My center line, if you remember, my center line, I haven't shifted this up or down at all. That's coming up in subsequent podcasts. okay? But I'm going to start my center line at 0. So I'm going to go up to 2, and I'm going to go down to 2. That's where everything has to kind of line up. Okay, so let's do this. All right, here we go. There's 1 right here. So 2 would be here. So I'm going to tell you, that's your maximum all the way across. That's your maximum all the way across. So wait a second, where's my minimum? My minimum's going to be, well, there's -1, there's -2, there's my minimum all the way across, showing you an amplitude of up to and down to. Ah, cool. Okay. What else does this tell you? All right, check it out. I have a period here of pi. And you know and I know, based on what I drew over here, that you have to have a complete cycle up and down. A crest, which is this top part, a trough, which is this bottom part, in pi. Okay, so where's pi? Well, obviously, I'm going to start here, and I'm going to end at, guess what? I'm going to end at pi. All right, so what does this mean? Well, let's do it. Let's do the entire cycle up and down. But wait, don't forget about that negative, which tells you you have to go down first. Oh, man. Okay, so I'm going to start here. I know I have to end here, and I know I'm going to have to go down first. Great. But where does this cut back? Where does this cycle start? I don't get it. Well, watch this. This is the cool part. Look how symmetrical this graph is. The up and the down are symmetric, which means, guess what? That's the halfway point every single time. Oh, okay. So I know I'm starting here. I know I'm ending here. Let's find the halfway mark. Well, 1, 2, 3, 4, 5. Oh, I went 6. So the halfway mark has got to be at 1, 2, 3. There's the halfway mark. And oh, look, at the halfway mark, it cuts the graph. Oh, so that means I'm going to cut the graph here. So I'm going to start here. I'm going to cut here. I'm going to end here. Lovely. But that's not all. Ha! Look at the halfway mark between this point and this point. Halfway is right here. That's the top part of your graph. Well, since you're going down then, halfway has to be the bottom part of your graph. Check this out. So you're starting here, halfway, 1, 2, 3. Halfway is 1.5. 1.5, guess what? You're going to bottom out right there. So you're actually going to see this portion of the graph right like that. Wild, hey? Check this out. This portion of the graph is also halfway. So count it, halfway. 1, 2, 3. Well, I knew that. So 1.5 has got to be right there. And check this out. Check it out. Look at that. Oh my God, yeah. There it is. There's your entire cycle. Isn't that wild? Now, here's the best thing about Magic Box, is that all you have to do is draw another Magic Box and just duplicate this silly thing again and again and again, as many Magic Boxes as you want, all based on the period pi, all based on the fact that this is your maximum and that is your minimum. Check it out. I'll do it again. So we're at pi here. Add another pi brings us to 2 pi. Guess what? There's the end of our box. Count just to make sure. 1, 2, 3, 4, 5, 6, just like the last one. Where's the middle? 1, 2, 3. So that means it's going to cross here. So I'm going to start here. I'm going to cross here. I'm going to end here. Because it's negative, tells you got to go down first. And down, you're going to hit rock bottom here. You're going to hit the minimum at 1, 2, 3. Oh, 1.5. 1.5, the midpoint right there. The middle. There's this section right there. Count again. 1.5. It's going to hit right there. There you go again. Bada boom. That's how easy it is. Watch this again. I'll do it on the left-hand side. So you started here, a period of pi, which was, again, remember, that period of pi was determined by this little equation that you used. You did it right here. 2 pi over 2 gives you pi. Okay, so there's my magic box up to here. Count. 1, 2, 3, 4, 5, 6. It's 6 again. No problem. So there's the middle part. You start here. You start here. I'll use a different color so you can see it. There you go. You start here. You end here. There's the middle. Okay. If you're going left to right, that's how all these graphs go. Start here. That means you're going down first. Find the middle between these 2 points. Well, that's 1.5. There it is down here. So there's the first part of the graph. Down here, cycles back up. The middle, 1.5. Right up to there, cycles back. Look at that. You've got the same graph again. Check this out. We'll do it one more time, the last time. So there's pi. One more period of pi takes you to minus 2 pi. There's your magic box. You just finished it. There it is right here. Look, there's your magic box right there, all the way around. Okay, so count. 1, 2, 3, there's your middle. 4, 5, 6, there it is. You can see it. Okay, there's your middle right here. So you're going to start here, you're going to end here, or sorry, start here, cut here, end here. Count 1.5. There's your bottom because remember, you're going down first. Okay, 1.5. There's your top. Okay, here we go. Let's do it. Look how beautiful that is. All based on something we called magic box. And you should have a nice, look how beautiful this flows, a nice flowing graph. Down, then up. And check this out. It flows just beautifully all the way through. And every time, if you remember when you did this, look at that. Every time you did this, all you created was the magic box. And the magic box was based on the amplitude right here and the period right there. Draw your magic box, and then basically all you have to do after that is rubber stamp.